All right, everyone, good afternoon. Let's get started. Actually, before that, two quick announcements. First, since the session is a bit short, please hold your questions until the end. We'll have if time is available at the end, we'll have a short Q&A, or you can reach me in other ways. And two, the slides will be uploaded on the web, so you don't have to copy anything from the slides if you don't want to. With that, let's jump into our talk, which is reading metadata in the line, reading metadata between the lines, searching for stories, people, places, and more in television news. I hope you are curious about this subtitle because you might be wondering about what this is all about. Let me first talk about what we do with television news. In UCLA's News Here project, we do all sorts of fun things with the news. We record about 100 news programs per day. They include national news programs such as CNN, Fox News, and so on. Then there are local programs such as daily news reports. There are also international news programs from other countries such as Spain, Denmark, Norway, and so on. We store them as an ongoing effort to preserve television news so that we can see what people watched in the past, and in the future, people will be able to see what we're watching today. We index them to make them searchable, and in fact, that will be the main topic for today's talk. We also make them available to the UCLA community right now and beyond in the future. We make the content available on the web, and this includes caption, transcript, image, video, and so on. This can be used in teaching as well as research and self-study. The material can be used for visualization, such as charting. And in fact, our users can annotate the news, and the annotations become searchable too. This presentation is about making metadata searchable. What does that mean? Television news can be thought of as a stream of words that news anchors and others speak, and the audience listens to. There's also an approximately word-for-word version, which is closed captioning in the United States for the hearing impaired. Closed captioning allows television news to be searched by words that are spoken and heard. But the news is also actually more complex. There are other elements on the screen in the structure of the news program and so on. Let's call them metadata. Unfortunately, metadata was not searchable in a meaningful way until recently, and this hindered the study of them as a part of studying the news. Let me talk about examples of metadata. The first example is story segment. Many news programs, such as daily news reports, are each divided into segments in which news anchors focus on covering one story before moving on to another story. For example, the anchor might talk about a crime that happened locally, and then move on to talk about a military conflict abroad. Having information about story segment in a program, such as where each story starts and ends, allows us to search for programs that cover a particular story, as well as limit our search to the coverage of a story. For example, recently this has been in the news a lot, the coverage of the Ebola epidemic. For many days, a lot of news programs spend a few minutes each covering the news. The latest development of the story. If you want to study media coverage of the story, you do not want to sort through dozens of hours of program each day with media coverage. You only want to look at programs that cover this particular story, and maybe only the few minutes per program that covers this story. And perhaps you only want to look at the certain segments if it uses a certain phrase. These are what you can do with some story segment data. In the news, there are name entities such as people, places, and so on. We are going to focus on speakers here. They have roles and other information about them that may not be mentioned in the program, but can be looked up. Having information about who is talking, when they start and stop talking, and so on, allows us to look at particular things that a news anchor or interviewee has said, or choices of words or phrases by people of a certain group, such as a political party. Because what people say often becomes more interesting because of who they are. For example, in 2012, after Hurricane Sandy hit the United States, the governor of New Jersey said that in a relief effort, the cooperation from the President of the United States was outstanding, and he deserved great credit. Now, this speech was unusual because in the United States, you don't often hear a politician praising another politician of another party, especially if the person being praised is the president. In addition, this happened just days before a presidential election. This factor makes the speech interesting. People communicate not just by words, but also by nonverbal means such as facial expression, hand gestures, and body movement. For example, here, Governor Romney was making his point with hand gestures. And here, President Obama was showing what some researchers call visual auditing, or what others call the stink eye. He was not saying anything, but his face expressed the message of, I do not think you are telling the truth. It would be very useful to note these expressions and where they are in the news, so that we can later search for examples of these expressions in the news. There are three types of information that the network presents. One of them is speech. Then another is on-screen images. A third one is on-screen text, such as headline, news ticker, city and country name, and so on. They might or might not be consistent with what actually happened and with each other. Most of the on-screen text is put there by the network and therefore shows how the network interprets the story. The most prominent text is the headline. Here, the headline says, Hong Kong protesters crash with police. But the police were actually driving protesters out of the area at that time. Police even aimed pepper sprays, ready to fire, at these unarmed and mostly peaceful protesters. Nevertheless, CNN has picked this particular headline, even though it's inconsistent with what actually happened, and the very images that the network itself has picked. Inconsistencies like this open up valuable possibilities for researching the truth versus how the truth is being told. Now you have an idea of what metadata search is and why it's important. Now let's consider how to make the search possible. First, let's help the user search. Give metadata a structure and set up a user interface to search this structure. There are different instances of metadata in our collection. An instance might be a segment in which a story is covered, or an interval when someone speaks, and so on. An instance has a start time and end time, such as when a story starts and ends, or when someone starts and ends speaking, and so on. The instance has a tag, which indicates the type of metadata. It also has attributes, which are name-value pairs and can vary with the type of metadata. For example, for a segment that starts at 1 o'clock, ends at 1:03, and it's a story about an Ebola scare in the United States, its metadata instance would look like this. We have come up with a user interface to search the data, and it accepts which attribute to search in, which word, phrase, or patterns to search for, as well as the rules such as match all words, match any words, and so on. We have also made it possible to search without specifying an attribute. This is helpful when they do not know much about the difference between different attributes or which one they should pick. Effectively, this means searching across different attributes at the same time. In fact, for users who are not familiar with the collection and just want to explore what's there, you have another interface that frees them from filling out a complex form. Instead, in this auto-suggest box, all they need to do is type some words or phrases, and the drop-down menu suggests what the user might be trying to look up, to look for. For example, if I enter Charlie Rose, 2 words, then it offers several extra suggestions of how it should interpret the words, such as Charlie Rose. Maybe I'm looking for the person who talked in the program, or Charlie Rose, the show itself, or Charlie Rose, the phrase, or Charlie and Rose, both words, and Charlie or Rose, either word. Now that we have the user interface, let's make the search happen under the hood. Solr provides a data model, a document, and a document can have a number of fields. Each field can be searchable and has a name, and can have one or more values. In our case, what should a Solr document and a Solr field represent? It's up to us. Let's say our Solr document represents a news program. There are other fields for program information, and in that, such as program name, program start time, end time, and so on. And in addition, let's say a Solr field represents one attribute. For example, there is one field for the story topic and another field for the person's name, and so on. Does this model work? Actually, let's modify our model a bit, because Solr also supports multi-value field. For example, the name field can have the names of everyone who spoke in a program. And the role field can have their roles, and the states field can have their states. Does this model work? In order to answer this question, let's consider what does this mean by searching metadata, and what interpretation would give meaningful results. For example, there's a serious drought in California. How are the state's politicians reacting? Suppose we want to search our collection with these 3 pieces of information. Caption text contains the word drought. The name entity row contains senator. And the name entity state contains California. There are several possible ways to interpret this query. The first interpretation is that somewhere in the program, and that could be 1 to 2 different places, the word drought is used, and maybe in another place, the word a person who is a senator spoke, and a person who is from California spoke. A different interpretation would be that instead of the drought occurring anywhere in the program, it has to be used by the speaker. Another interpretation, the person has to be a senator of California, but the word drought can be used anywhere in the program. Then there's the fourth interpretation, which is the same as the previous one, except the word drought has to be used by the speaker. Now, which interpretation is correct? It really depends on what the user is looking for. This particular interpretation is useful in many cases, for example, to find out what a person or a group of people has said. Does the model about solar document and field work and support all these interpretations of the query? The answer is, it works for some, but not all of these interpretations. It works when we're searching for stories about Ebola, or when a senator spoke, or when a person from California spoke. However, it does not work when we are searching for when a senator of California spoke. Suppose a program has exactly two identified speakers: John McCain, a senator of Arizona, and John Chang, a controller of California. We know that this program should not be matched. However, this program is matched by the query because row equals to center is here, state equals to California is here. We know that we have a problem. Let's solve this problem and make the search meaningful. To address this problem, let's modify our model. It now has two levels of documents, made possible and very fast by Solar's support for block join. At the bottom are tag documents. They contain the metadata instance content, such as story topic or person's name, and so on. Here, one Solar document represents one metadata instance. Above it are documents of another type, which we call program documents. They contain program-level information, such as date and network and show. And here, one Solar document represents one program. Then searching can be done in these steps. First, you search for words and phrases, enter in the fields of tag documents. Then, after we have some tag documents, with block join, we look up corresponding program documents. After that, we can do additional filtering by program information, now that we have the program documents. And the program information can be like network, shows, and program date. For example, if we want to find when or where a senator of California spoke, first, we find tag documents that have the row senator and the state California. After that, we find parents of these documents, which is we find the program documents. After that, the program documents in the intersection will be in the search results. Now we can return to the use case of searching what a person or a group of people has said. Instead of finding all instances of the word drought, being used anyway. Let's find instances of where the governor of California has used it. It can be done by first searching for the word drought, and then filtering and keeping only the matches that are within the time when the governor of California has spoken. We have the start time and the end time of the segments in which the governor of California has spoken, as well as the time at which the word drought is used. Then the filtering is just a matter of comparing the word's timestamp against the start and end time of the name entity's metadata instance to see the word, if the word is within the segment. For example, here, the word drought is used, which is within the time range when Governor Brown spoke. Therefore, we know that this instance of word drought was used by the governor. Now the search is useful and meaningful. Can what we have learned also make the search even more powerful? Luckily, yes. Here is one way. We know that Lucene and Solar support proximity search with words as a proximity unit. That is, searching for words within this number of words of each other. For example, here the word drought and the word lawn are 20 words apart. With time information, a related type of search that we can support is proximity search with time as the unit, which means searching for words within this number of seconds of each other. For example, here the word drought and lawn are 6 seconds apart. If we use a query that asks for proximity of no more than 30 seconds, then this match is kept and shows up in the search result. However, on the other hand, if the query asks for proximity of no more than 5 seconds, then this match is filtered out and does not show up in the search result. To summarize, what are these designs and techniques for? Remember the mission from the beginning of this talk, where I said that metadata was not searchable until recently. Thanks to Solar, the metadata in our collection is now searchable, along with the caption. Now, I encourage you to think about your data. Are there similar metadata in your collections? Are all types of metadata searchable and in a meaningful way? If not, then it's my hope that perhaps the designs and techniques in this presentation might help make your metadata searchable. Again, I would like to thank all of you for coming. The slides are available at this address, or you can scan this barcode on your smartphone and it will take you to the page. If you have any questions or comments, I'll be at the conference today and tomorrow. You can use the app for the conference to submit questions, and you can always email me at this address. And since we have about 6 to 7 minutes left, I can also take some questions now. Yes? Can you repeat the question? Image detection?
Image recognition. So you get images and process images. Is that correct?
On the research side, okay, excuse me. So the question is, do we do any image processing and detection?
Yes.
The answer is we do. On the research side, we are looking into image detection, mainly focusing on, for example, person detection. For example, if a program looks at the news footage, can it detect the people who are in the news footage? Yes, there are some research into that, and there are some programs that we can run to recognize people from the images in the news material. Although I would say that it's not quite production ready. It doesn't have a lot of recognized data in our collection right now, but we are working on it, and hopefully when time passes, we can have more of such data, because we know that it will be very useful to add to the name entity recognition collection. Does that answer your question?
Yes. So for now you are mostly using captions, right?
Yes. Although we used to only have captions as the searchable material, but we're now adding metadata as searchable material. So you can search for caption as well as metadata.
Okay, thank you.
Yes.
I wonder if you tried indexing, denormalizing your data and then using group by as opposed to trying block join, and how did performance of the two approaches compare? Like basically taking the fields of the upper level documents and then indexing them in the lower level documents and then just searching at the lower level as opposed to doing a block join?
Okay, so the question is, have we looked at grouping?
Yes, grouping versus block join. How does that compare in performance?
Right now, we have mainly looked at block join. We haven't spent relatively a lot of effort looking into using grouping. But it looks like block join does what we want to do, because after we have matches at the tag document level, we need to find out which program that we have matches in, and we display those programs, and then we display the highlighted matches and so on. Therefore, in the process, we need a way to find out the programs that are matched, and it looks like it is something that is very convenient to do with block join. But to answer your question, if it turns out that using grouping is a better way, or at least a comparable way, I would like to know about it, and we can talk about that.
No. Block join is supposed to be the better way, but I wondered if you had some hard performance measurements. Yeah.
We haven't done like benchmarks or so on, but in our experience, block join has worked really well for us. It's very fast in terms of performance.
Thank you.
You're welcome. Any other questions? Yes.
Yeah, in your text proximity search, are you actually putting in the second, like each word was spoken, and figuring out a distance based on that? Or is it just you're making an assumption based on the distance of the words from each other? How many seconds elapsed?
So the question is, are we actually using time information to search versus using distance information together with an assumption about
Exactly.
time, conversion between time and word distance?
Right.
My answer is we actually do have time information when we record the program, we know approximately what time a word appears in the program. Therefore, we can actually calculate the time distance between the two words, because we know for both words, we know where they appear within several seconds in the program.
Okay, that's interesting, thanks.
Oh, I think our time is up, but you can ask, if you have any questions or comments, feel free to contact me. And again, I would like to thank all of you for coming.